Hello, 6th grade students. So today we are beginning our unit on astronomy. So that's why I put up this poster today. It has the solar system and all the planets in there, and we'll talk about more planets in a later lesson. But today's lesson is going to be on gravity. In order to understand all of this and how this works and how it's able to stay where it is, we know what gravity is. So this is just going to be a lecture. I don't have anything for you to do in your science notebook for this part, but there will be a check your understanding assignment, so make sure you pay attention. And all of this will be relevant information for the rest of the unit. So you have to know this to know the next thing, the next thing, the next thing. So it's still very important to listen to. So we're talking about astronomy. What is astronomy? We all have ideas about it, what it is. We often think of this, the solar system. So the definition of astronomy is the study of everything in the universe beyond the Earth's atmosphere. Think about that for a minute. So every other science is about things that happen within Earth. So biology is the study of life, chemistry is about the elements, and we know that these elements are on Earth. We don't know what other planets have for elements. Not every planet has all the, well, as far as we know, no other planets have all the elements that we have. So chemistry is derived from that. Now, all of these branches of science are involved with Earth, except astronomy. So think about all of the other planets, and then within planets you have, you get some together and you get solar systems, and then you have galaxies, and all of the galaxies in the entire universe. Studying any of this is all falling under one category of science, astronomy. So that is pretty unfathomable for me, thinking about how vast that could be. Does physics work the same on another planet? What about chemistry or biology, life on other planets? We don't even know. We need astronomy first to be able to get there. Okay, so astronomy. For the very first thing we need to talk about is gravity. So gravity, before we give you a definition, I'm going to tell you a story. So this is a myth. I'm not sure if it's true, but this is how it's been taught to me and for generations, is that there's this guy named Isaac Newton. This part's not a myth. It definitely was Isaac Newton. Isaac Newton was sitting under a tree taking a nap, maybe waking up, and an apple fell, and he saw it fall. And he thought to himself, why did that apple just fall straight down? It didn't break itself off and go sideways, and it didn't go up. But when that apple came down, or came off the tree, it went down, straight down to the earth, to the ground. And he thought, well, there has to be something pulling it to the earth. Otherwise, it would just float around, or go sideways, or up, or any other direction. But the reason it came down, he thought there was some force, something pushing it or pulling it to the center of the earth. And he turned out that idea turned out to be correct, and this is called gravity. That force that's pulling things to the center of the earth, that's called gravity. So thinking about, I'm sure you guys have seen videos of space and people just floating around. It's because there's less gravity there pulling them to the center of the earth or the center of the moon, so they're just floating around. And because of gravity, things fall and they stay in place as we experience life on Earth. So we wouldn't be able to we wouldn't have life on Earth if we didn't have gravity. Think about plants. Plants wouldn't be able to stay where they were. Or, I mean, I'm in a classroom right now with desks. These desks would be flying in my face. You probably wouldn't even be able to make a desk because all the materials would be flying everywhere. You wouldn't be able to cook things. So, yeah, or water. Think about water. We need water to stay in one place. If there was no gravity, the water would just be flying around. And there probably wouldn't be, there wouldn't be an environment for water to have even been able to exist. So, gravity is very, very important. Now, gravity is, let me give you Isaac Newton's definition. So Isaac Newton's the guy who's sitting under the tree. He's a scientist accredited for coming up with the idea of gravity. So he says it's called Newton's law of universal gravitation. So think of that. Newton's law of universal gravitation. Law means this is true over and over and over and over again. So it becomes law. So how we did the scientific method, and we did it. No, the last step was the conclusion, and after the conclusion, another scientist could go back and do the same experiment again. So a theory is when you do that over and over and over again, and you get the same results over and over and over. And then sometimes you do that so many times, even when it's a theory, that it becomes law, scientific law. So the law of gravitation, basically just saying gravity, it's just a fancy way of saying that, gravitation. So if you hear someone say gravitational pull, it's talking about the force of gravity. So Newton's law of universal gravitation is between any two objects in the universe, there is an attractive force, gravity, which grows greater as the objects move closer to each other. So this is saying that there's two objects anywhere in the universe, and there's a force between them that pulls them together. That force that pulls things together, that's called gravity. So we know this from looking at the Earth and seeing if you drop something. That's one example. But let's take it a step further. So we already know the example, you drop something to the Earth, it's because that object in the center of the Earth have an attractive force, and it's pulling that object to the center of the Earth, because the Earth is bigger, and there's a whole mathematic equation for that. It's the thing that has more mass that gets other things attracted to it. So it's not that, so if you had an apple that's falling from a tree, the Earth isn't going to rise up and meet the apple because the apple has less mass. Instead, the apple falls to the Earth because the Earth has more mass. And that's a whole equation and goes into math and physics, and that goes more into high school stuff, so we won't get so far into that, but just know gravity is the force between two objects, and the one that has more mass is the one that gets the thing attracted to it a little more. Okay, so that is the universal law of gravitation. So let's talk about some examples of gravity. We talked about the object and the Earth. Now thinking beyond the Earth, we want to talk about astronomy, right? So Earth and the moon. There's a gravitational force between those two objects. You have the Earth and you have the moon. So try to make one big and one smaller. The Earth and the moon. And there's a force between the Earth and the moon called gravity. So why doesn't the moon just fly away from us? Why hasn't it just left us? Well, it's because there's a force between them, between the Earth and the moon, that's holding the moon where it is in relation to the Earth. And that force is gravity. So an implication of that you guys can see is ocean tides. So ocean tides, I know we don't live in the ocean. We don't live near one, but when you're near an ocean, you'll notice that either the waves are coming in, so you have the shore, the ocean shore, and the waves are coming in, and slowly they'll come in. Or they're slowly going out, and they still crash this way. But the water, where the water and the shore meet, that water line between where the water and the shore meets is either rising or falling back. And the reason it does that is because the moon and the Earth have that gravitational pull, and that the seawater is attracted to the moon and it's being pulled. So that's interesting. That's where tides come in, and that's why they happen. And it has to do with astronomy because we're talking about something outside of the Earth's atmosphere, the moon. So you have the moon and the Earth, and there's a force between them, and it's why the moon's not leaving. So you can think about this with other parts of the world as well. So we have the solar system here, and this here's the sun, this whole thing, and these are each of the planets here. And each of these planets is in orbit, meaning it circles around, or it could be an oval, but it's moving in a predicted motion around the sun. And it's always in this order. So never will Mars be closer to the sun than Earth is. It's going to go Earth, then Mars, because they're in orbit, and that's how it's been, and that's how it will be. But why don't these planets just leave and go to another galaxy? What's holding them in? It's that there is gravitational pull between each planet and the sun. So that force between two things exists between the sun and each of the planets in our solar system. So we have the sun and, let's say, Earth, because that's our planet. But there's also Mercury, Venus, Earth, whatever, and we'll learn about all of those. You'll have them down later. But the reason why is because there's this gravitational pull between each planet. So we'll have Earth and the sun holding them together. And so why? So how do I say? So we talked about how the apple, it's not that the Earth rises up to meet the apple that's falling. It's that the apple rises or is pulled down to the Earth. So thinking about that, how mass affects which one is attracted to which, it makes sense then that the sun is larger than any of the planets. Because the sun has more mass, it pulls things to itself. So yes, that's how these are not flying away. It's because the sun has a gravitational pull on all of its planets in the solar system. And similarly, the Earth has that pull with the moon, and that's why the moon's not leaving us. And that's why all the desks in the room I'm sitting in, or teaching in right now, are not floating away. It's because the Earth is pulling these desks to its center. Okay, so I believe that's all for today. We talked about what is astronomy. So things to remember. What is astronomy? What is gravity? Who is responsible for coming up with the idea of gravity? And know that little story behind him with the apple and everything. It's just a well-known story. And then also, we know what is gravity. So that was part of it. What is gravity? That force between two objects. But then I also want you to know how mass matters. Because the bigger something is, that's going to be the thing that's pulling things towards it. So if two things are the same size, they'll still have gravity between them, but they're equally pulling each other. So maybe like this, how I'm equally pulling two fingers. But yeah, just think about how mass matters in that. So if the sun was really tiny and didn't have a lot of mass, then the solar system wouldn't look as it did today. So that's all for today.